Alrighty, just wanted to record a session of me just working on some things in the GPT-SoVITS package that I'm making. And so, yeah, just gonna be doing that. It's a chill offline live stream type of deal. I'll just be talking through some of these things, sometimes mumbling to myself, or not sometimes, but mumbling to myself while I'm working always helps me think things out loud. Okay, so today's problem that we're trying to resolve, well, not the problem, but what we're going to code up is just a reference Python module that can be that shows how to use the package for just calling the text-to-speech without streaming. So I have one here that does the streaming call. So we're going to take this apart and then just use the regular callback. So it is going to be for my audiobook maker. Yeah, so I can just start working on that. Just get this going. Text to speech. Call example. QA. We can pretty much just copy this, paste this into here, and we're gonna be pretty much using the same stuff, but I don't need this playback thread. Don't need that. Set seed. I could probably use set seed actually. Yeah, we won't need this. We won't need this. I won't need any of these. And since we're not doing, since we're not using a generator function, don't need that, don't need this. Pretty much, we will just need this, this run function here, but we'll use the other run that's inside of TTS, which is here. Okay, cool. So I'm gonna make it a little bit larger so I can see more things. But yeah, we can pretty much just call this, and it should be pretty hands off. Run. Import TTS. Okay, cool. Do pipeline. Which is TTS here, configuration, initialize all the stuff, and then pass the parameters that we want. And then I might as well add a seed here. In okay, we'll do one seed one, slap on seed there, and pretty much that is it. Now let's see what this returns back. Right, so return fragments. I wonder, so I actually didn't notice this when I was implementing the run generator down here, but it looks like we can yield back tokens or yield back fragments with this run function here. Maybe I should try that out. Return fragments. Okay. Step by step, return the audio fragment. control the interval of the audio fragment. Huh. Interesting. Okay, let me actually see if Cursor can write me up. Yeah, let me finish my call example first, and then we'll make another one to test out that run function, that run function with the return fragment. So first I gotta figure out what it returns back in the run. So back to what I was looking at originally. And then if not, ends up yielding all of this stuff here. False. 1, 2, 3, 4, 5, 6, 7. Can I return all of those back into as a list? Let's say a function for me. A function returns this. Cannot I take each parameter? Can I instantiate a list and just list, let's call like this, and when it's returned, access audio by doing list x. Alright, let me ask, because if so, I can just do, I don't know, say something like I think I can do something like this, huh? Maybe. Because it yields, so I have to call it. Where function contain the yield. To pull up the values it yields. Entire generator list and then index it. I can give it back one shot. Builds up list internally. Okay. Well, let me run this, see what it gives me. Right, load the models, get all of those loaded in. Okay, enter to continue, and we are going to run it. All right, so we'll do the whole thing. All right, what does gen look like? Gen is a generator object. Yes, run it on gen fragment. Okay, so I guess we're looking for fragment. Fragments returns Oh, just returns the array of numbers. Oh. Okay, it just yeah. This is calling to audio post process, not returning back each one of these. Okay, that makes sense. So it's just gonna return back one audio stream, or one array of what is it? One array of a bunch of numbers that I can save to an audio file, and then that should be what I can play out. Alright, I understand what's going on. Okay. Okie dokie. Let me stop playing that there. Alright, inside of call example here, can you put to a folder called outputs? Now let's see, wave text outputs, and store those inference files in there with increasing suffixes. Alright, do that there. Post-process. Alright, what does post-process? Okay, yeah. Post-process returns sample rate and audio. So yeah, that's why we need both here. Alright, for index, append fragment out. I'll accept that change. Okay, cool. So, should be good to go here. Oh, I should remove this loop. No, I'll leave that loop. There's inference there. I'll call this TTS outputs instead of text outputs. Okay, so here we go.
Hey there. This is a test of the TTS streaming. Is there anything that I can do to help you out? Or maybe you'd just like a quick snack?
Let's regenerate.
If not, that's okay too.
Same seed,
I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Right, 384. Let's listen to this here.
Hey there. This is a test of the TTS streaming.
Okay, cool. Sounds the same, which is perfect. It's good for index. This actually isn't how I wanted to save it. So do this. Say index is 0, and then let's see. How does this work again? While while OS path exists out path. All right, perfect. While okay, index +1. All right, cool. There you go. That got it out. Right, running again. Just going to test it out one more time. Make sure the suffix counting or the suffix incrementalization is correct. So we should get inference _1 here, then 2, 3, so on and so forth, yada yada yada. No longer initialize generator. Setting an array element with a sequence. Okay. Let's see. Why was that the case? Let's see. File data sample rate. What was the error again? The shape is incorrect. What was the difference? For index setting an array element with a sequence. All right, what does this mean? Should be able to add this to the all right. Alright, but if I do this, it'll probably fix it because this is what I had. This is what it was before. What was it? Yeah. Okay. Alright, so that saves correctly. That's because I set it to 0 here. I think. Wait, what? Wait, hold on. While OS path exists, shouldn't out path have been? Shouldn't out path have been updated with this index value? What's going on here? Mm-hmm. Oh, I'm looking in the wrong folder. Psh, that's why. Let me delete this so I don't get confused. Alright, here we go. Now it's working. Or it's been working, but now we're looking in the right spot. Alright, let's see. It's coming from sound file, fragment, blah, blah, blah. Must is a Python sequence link to the sequence to a jagged list of two lists rather than a rectangular. Generated incorrectly. Okay, so it's returning so what you think is a fragment is actually a tuple or a list of two pieces. So there's two items into there. Okay, now let me see. The difference between this and this. In this case. Alright, so I don't fully understand this area of accessing or this area of the generator function for the for loop, so I'm just going to clarify and figure that out so that I know for the future. Alright, cool, but this works. So in case I need a reference script or module for me to reference in the future for this package, I've got one example here. I always do that because I'll forget how to exactly instantiate everything and then how to run the inference on it. Alright, let's see what you do. Happening yields pairs of the form index gen element. Okay, index into gen element. Take each item from assign sample rate equals index. Oh, enumerate. Right, enumerate assigns this index value to or returns back this index value. Okay, so if I just did, I don't need that index value, so I don't need enumerate. So if I just did this, I think I would be fine. Yeah, since I don't need the index value in this case, because it doesn't really matter. I'm just doing a single inference. I don't need, and I'm, sorting the suffix outside of the call function. I don't need that enumerate. I don't think so. Yeah, so, okay, this will work. I remember looking up what the heck does enumerate do versus just calling it directly on the generator function. Alrighty, now we're back up to speed. That'll work. I like that better. And we don't need to append the fragments. That's just a waste of space. I'll say enter to generate. Remove that. Alright, seed, cool. And then I should also add seed into this zeros crossing. Example 2. And then I'm going to rename this test. I'll call this streaming example. ZC stream zeros crossing streaming example. Okay, and we'll do that. And then now I want to create another one to test out the run frags to see how that return fragments works. Alright, let's do this here, this, and then we're gonna say we're gonna start a new chat. And then, oh, let's say, can you make this Python script compatible with passing return fragment at intervals of 0.5, and then we can just throw this into the chat. Drag this into here. Alright, send that. And then I will wait for a response. So yeah, this is I didn't know that the function run, or yeah, the function run has this return fragments parameter. So I'm curious as to what this will yield instead. I feel like I had tried this when I was originally making my run generator modification like a few months back, and I think there was a little bit of an issue with it. I think my general issue with returning a set amount of audio back is that you end up getting like this choppiness issue. So when you're playing out audio, you'll hear pops in the audio playing out because of the like the chunk ends on like a higher on what is it? Not volume. Yeah, the chunk ends on an amplitude that is higher than 0 or is like loud. So when you just cut off that audio and then slap on the next fragment right after it in sequence, you would think that it would continue to play smoothly, but there's a loud pop because it sharply cuts off the audio. That was not a very good explanation of it, but we'll see if we can replicate it here. All right, let me see if I can demonstrate it. And that's why I came up with the zeros crossing module, or the little algorithm here, because of that popping that was occurring when I was returning back just static chunks. Alright, so that didn't do it. Let's see. Okay, segmented audio. Okay. Inference. Why does it still return back a whole chunk? If not... else? Okay. Maybe I misunderstood how this works. Yeah, I might have misunderstood how this return fragments works, so... Huh. Alright, well, I'm not going to dive too much deeper into this return fragments section of the code. Because, yeah, I'm not going to be using it. So, alright. We'll remove that. Don't need that Python function. I will delete that. Okay, cool. So made my little call example modification here. What I also wanted to try to get to was to see if I can make this a little bit more optimized and figure out a way to run this generator function maybe in the background without having to have the audio like to be able to generate the entire audio form or the audio output in one go instead of having to fragment it. Okay, let me re-explain on my thought process here. So this function, when it's calling the run generator function, it returns back little chunks that are the spoken TTS. But the issue is that I want to try to get access to that first chunk as soon as possible. So to normally do that, I would reduce how many audio frames are accumulated to, let's say, like a smaller number so that it generates less tokens before it returns back those tokens. But the issue is that when you start to reduce the amount of tokens that accumulate here, it reduces the inference speed by almost like 4x. So I think to show you an example, I'll run it with 30 for the accumulation amount. And then we'll look at it with 100 for accumulation amount as a comparison.
Hey there. This is a test of the TTS streaming. Is there anything that I can do to help you out? Or maybe you just like a quick snack. If not, that's okay too.
Okay.
I'm just here to chat.
So I'm going to stop it there. As you can see, we've got an average of about, let's say, 25 iterations per second here. Whereas if I slap this up to like 150, for example, the iterations per second is going to increase by quite a bit. And I think the reason for this is because it reduces the efficiency of the GPU when it's trying to process the output. And so if we run it one more time, we should see that number decrease to, or increase by quite a bit. So we got 81, 69.
Hey there. This is a test of the TTS streaming.
41.
Is there anything that I can do to help you out? Or maybe you just like a quick snack?
Okay, and so if you might have noticed it or not, but the time to spoken speech here was quite a bit longer because we had to wait for more tokens to be generated. But the first example, we got to hear audio a little bit faster. However, because it's now not able to generate the audio samples fast enough, it ends up becoming choppy. This second one was at about, let's say, like 65, maybe average of 50 iterations per second with this last one. And so I would like to be able to try to get this speed, the speed that comes with larger token accumulation, with the benefit of accumulating less tokens. So I was thinking if I could run the generator continually for the entire audio sample in one thread, and then have it return back chunks that can be converted for like the first, I don't know, like 3 to 4 audio samples, while meanwhile the fast generation's running in the background. And I feel like I had tried to do this way back when I was first thinking of this problem, and I ran into some issues, but I don't quite remember exactly what. So we might run into those same issues and trying to re-implement that. But yeah, that's just my brain thinking through the problem here. And so we are going to use our handy dandy cursor here with O4 Mini to try to work through this problem and see what type of solution we can come up with. Right. So this is it here. And if we go into this, function, where the heck is it? Infer panel generator. I pass in a accumulation amount that tells it to stop at a certain number, which will yield back those tokens. And so I wonder if there's a way to yield back the tokens without stopping the generator. So where is my yield generated tokens? Okay. So let me first ask a question. Is there a way to yield back tokens without having to stop this function? So ideally this would be what I want to do to make sure that this inference function doesn't have to keep being recalled and reinitiated. But let's see. Yes, you don't need to run the entire loop. Okay, for example, if you want every single token as soon as it's generated, okay, so yeah, how slow is it if I just run it with an accumulation amount of 1? I bet it's going to be super slow. Alright, let's wait for it to load up my models. Yeah, I'll come up with my question though. So the issue is that, here, run it through that. Yeah, so that is super slow. Okay, so the issue is that each time the for panel generator is called, it incurs quite a bit of additional latency with it. So I was wondering if there is a way to have it keep generating, but also being able to return back some tokens once a certain amount is reached. Yeah, I don't know if there's a way to return back the tokens once a certain amount have been reached. I mean, this is kind of like where threading comes in and all of that. I don't know if that's applicable in this case. Okay, you don't actually tear down and relaunch the entire decoder every time you want a token. As soon as it's produced. Maybe, I wonder if I comment out the part of the code that, decodes it, if that would be, if I'd be able to test, how much faster it is. Now I'm gonna run into some errors with that. Okay, under the hood, each yield pauses the model in exactly the spot where it hit that yield statement. No full down, tear down. Okay, maybe my assumption is incorrect here. So I want to test my assumption by I want to test my assumption. By commenting out this. I think I should be able to comment this out. And then print length of gen list. Okay, so if what the model says is true, then the iteration speed should be about the same, about 50 to 60, as when we're trying to accumulate lots of tokens. So maybe the VITS model here is causing the reduction in speed. I don't know, we'll see. Okay. So I learned something new. It seems like the additional overhead isn't incurred on the generator function. The additional overhead is incurred on all of this additional logic here that is used to process those tokens. Okay. Alright, so how do I do this? Maybe I can have a dynamically adjusting accumulation amount. Okay, let me try it with that. Alright, I guess we'll add dynamic accumulation. Accumulation equals inputs dot get was false. Accumulation amount. Let's do 10. Alright, let's go to nice. Did it for me. Let's see, true. Right. See, else, and then I can say if dynamic accumulation amount. All right, there we go. And that should do it. Let's start at accumulation amount of 30. So this will do let me see if my queue is waiting for 2 audio fragments. Okay, yeah, so this is still waiting for 2 fragments. So I should be able to do accumulation amount of 20. So 20 plus 30, that'll be 50. And then the next call will be 40. Then it should go 50, 60, 70, yada, yada, yada. So let me see if this is any faster. Alright, so we got 1 sample, 2 sample.
Hey there. This is a test of the TTS streaming. Is there anything that I can do to help you out? Or maybe you just like a quick snack. If not, that's okay too.
Okay, so I think we have a little bit of a failure here because the amount of tokens being generated is I'm gonna stop it there because the amount of tokens being generated isn't increasing. All right, so where did I go wrong here? Dynamic accumulation is true. Maybe I didn't save it. But let's see, dynamic accumulation. Let's run it again and try to see what it stops at here. Okay, so accumulation amount should be 30.
Hey there.
It should be 40.
This is a test.
50. Bring me back. Oh my goodness. Exit out. Okay, there we go.
Of the T.
Oh. Okay, so it doesn't adjust the parameters in here if I pass it with that. Okay, so I have to do I have to also pass this in here. Okay, I take this out. Okay. Token since, yeah, last yield. Relation amount. Alright. If accumulation. Oh, wait. No, I need to update my. Okay, so now this should be adjusting my tokens that are being yielded back because it's within that function itself. Okay, cool. Ready? I'm gonna do that. Alright, so we should
Hey
start to
there.
see this increase.
This
Yeah,
is a
there
test
we
of
go.
the TS streaming. Is there anything that I can do to help you out? Or maybe you'd just like a quick snack. If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Okay, cool. So I think that works. Let's try that one more time. 10.
Hey there. This is a test of the TS streaming. Is there anything that I can do to help you out? Or maybe you'd just like a quick snack. If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Alright, so that is... Let's try to increase accumulation amount by 20 each generation. And I will time this. Let's do start. Close time. Alright, import time. Alright, start time. No. What is this? Yeah. This should be when it starts to speak here, actually. End equals time. Time taken to put first fragment. There we go. Okay, so with accumulation amount of 20, dynamic accumulation amount of 20, this should accumulate up to 60 tokens first, and then it will be at 60 tokens, then 80, then 100 for the next few generations, or frames. So let's try that out.
Hey there. This is a test of the TTS streaming. Is there anything that I can do to help you out? Or maybe you just like a quick snack. If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Right, where is time to first fragment? Time. Oh, oops. Should put this here. Yeah. Alright, messed that up. Oh no, I'm gonna run into a JSON Python issue. Alright, yeah, this happens if I close out of the while true loop unnicely and then try to relaunch in VS Code, or in this case cursor. And VS Code is the same behavior too.
Hey there. This is a test of the TTS streaming. Is there anything that I can do to help you out? Or maybe you just like a quick snack. If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Alright, so we'll do the second generation, as it's usually a little bit faster to the first token, so.
Hey there. This is a test of the TTS
so
streaming.
1.2.
Is there anything that I can do to help you out? Or maybe you just like a quick snack. If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Okay, so that is 1.2 seconds to first token. Which is great. Because now if I turn this to false, we'll see what it is. And then if I turn this to false and just have it at a static 60, which is what it was dynamically adjusting to for the additional generations, we should see that the time to first token is a little bit longer. So remember, it was 1.2 seconds for the dynamic accumulation.
Hey there. This is a test of the
1.6.
TTS streaming. Is there anything that I can do to help you out? Or maybe you just like a quick snack. If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Okay, so we're gonna do that one more time.
Hey there. This is a test of the
1.4.
TTS streaming.
1.5.
Is there anything that I can do to help you out? Or maybe you just like a quick snack? If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Ready? Cool. So from 1.5 to from 1.5 seconds to 1.2 seconds. That is like a 20% increase, I think. So that's pretty good. Yeah, that's a substantial increase. Now I wonder if I put the accumulation amount to 10. Let's do true. So this will be at let's do 20. So this will be at let's see, 10, 30. Maybe I can do 30 here. So this will be at 40. And then the second one will be at 10, 40, 70. Second one will be at 70. I might be able to get away with this. Let's try this.
Hey there. This is a test of the TTS streaming. Is there anything that I can do to help you out? Or maybe you'd just like a quick snack? If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Okay, so 1.3.
Hey there. This is a test of the TTS
1.14.
streaming. Is there anything that I can do to help you out? Or maybe you'd just like a quick snack? If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Okay, so those are some gains. That's pretty good. Let's see if we get
Hey
any
there.
faster. 1.12.
This is a
Okay.
test of the TTS streaming.
Alrighty.
Is there anything that I can do to help you out? Or maybe you'd just like a quick snack? If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Okay, so the it seems so the limiting factor here is that VITS decoder. So when it decodes those tokens, we incur that extra bit of generation latency. And so we have effectively, with the dynamic accumulation, reduced it from 1.5 seconds to first speech to 1.1, which is a substantial improvement, percentage wise. Perceptionally wise, maybe it is perceptionally wise. I wonder if there's a way to get this faster, but I think we are running into because I'm doing 2 fragments for the first bit of audio. Before the first bit of audio starts speaking, I'm still incurring that additional VITS latency when it does the VITS decoding on those 2 first fragments. So I don't know if by decreasing accumulation amount, if it's going to make it any faster. Probably would require some fine-tuning, or not fine-tuning, but just playing around with the parameters here. Now if I reduce the amount of VITS steps, obviously we can start getting the audio sample out a little bit faster. We could run this at 4 for sample steps, and this should allow the VITS inference to run a little bit faster on those tokens. So yeah.
Hey there. This is a test of the TTS streaming. Is there anything that I can do to help you out? Or maybe you'd just like a quick snack?
Okay, so 1
If
second.
not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Okay, so we've got that at 1.0 seconds. Let's try one more time.
Hey there. This is a
0.8
test of the...
seconds. Okay, cool. So 0.8 seconds if we reduce sample steps down to 4. As you reduce sample steps, you also reduce the inference, the overall inference quality. So it's kind of a balancing act here. You want speed, you want quality. 4 actually didn't sound too bad, but I don't have my headphones on. I think there's always a little bit more of a metallic sound the more that you start to reduce sample steps. As I believe it's a diffusion model for the decoding here. Okay. I mean, 4 didn't sound too bad. I think for reducing the speed by about half, if I turn this to false and then I put this to 40, this is effectively what we would be at for static accumulation. We can compare, let's see what the time to first fragment is going to be for this. I mean, it shouldn't be too much, but
Hey there. This is a test of the TTS streaming. Is there anything that I can do to help you out? Or maybe you just like a quick snack? If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
okay, so that let's see.
Hey there.
Yeah, about 1 second. By decreasing from 10 to 4 for sample steps and then just having it be static. I also just remembered the way that I had to implement the VITS decoding. You might have noticed, but if not, that's okay. The iteration speed slowly increases or decreases the more samples that are generated. So as you can see, we go from like 56, 58, 52, 56 down to 50, 47, 41, 40. And that is because I totally forgot I had to do this for the implementation. That's because as this as the audio stream gets longer and longer, each VITS decoding call is actually decoding the entire audio array of tokens. So the reason that I had to do this was because if I tried to use the VITS, if I tried to decode the tokens in each batch with just those tokens, I was getting different sounding audio out of it for the output. And I think that's because it doesn't have context from the previous tokens. So to resolve that, I am just running that VITS decoding on the entire audio sample each time with that entire audio array, each time to make that a little bit easier, and also to make the zeros crossing and the splicing of the audios simpler on my end, because I can just keep track of the tokens from the beginning of the list all the way until it finishes up, and I can use a certain index of that list to find where to do the splicing, yada yada yada. So I remember that I did have to implement that when I was first doing this or making this modification. So that is also where we run into some latency. I don't know if I can make it any faster off the top of my head here. If this is the limiting factor for inference speed. I think that dives into model architecture and everything like that, which is a little bit beyond my grasp and expertise at the moment. But yeah, by modifying some of the parameters and changing how much tokens we generate and decode, it looks like we're able to get it down to about 0.8 seconds to the first bit of audio. And I'm sure there's a few like modification or not modifications but parameter adjustments that can be done here to find the optimal parameters for whatever device you are on. So I'm on a 4090, and that makes things process pretty nicely. But yeah, I don't know how this would fare on my 3060 computer, which I'll have to try out. Right.
Hey there. This is a test of the TTS streaming. Is there anything that I can do to help you out? Or maybe you just like a quick snack.
Okay.
If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Alrighty, let's try that again.
Hey there. This is a test of the...
Okay, so half a second to first fragment. So we're getting faster and faster. So maybe this is what'll work on my computer, 10 and then 20, because then the second one that's generating is going to be 50. Now if I maybe say, if I make this a continual sentence, I wonder if it'll change. Today we are going to be testing TTS streaming audio. We'll just use this for the first sentence. And we'll see if we can hear an audible splice or choppiness in the first couple of fragments. That's the big issue, is you don't want to hear that choppiness in the audio, or else things start to sound a little unnatural in speech. So let's try that.
Today we are going to be testing TTS streaming audio. Is there anything that I can do to help you out? Or maybe you just like a quick snack.
Okay.
If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Alright, let's try that again.
Today we are going to be testing TTS streaming audio. Is there anything that I can do to help you out? Or maybe you just like a quick snack. If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Okay, cool. So that still sounded fine. Now, what happens if I remove this? Move this out a little bit and just allow it to return and say out the fragment immediately. Here, let me change these guys here. All right. We'll hear the audio faster, but we will probably hear a little bit of choppiness between that first fragment and the second fragment.
Today we are going to be testing TTS streaming audio. Is there anything that I can do to help you out? Or maybe you just like a quick snack. If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Okay, so that ended up sounding a little strange overall. Let's see.
Today we are going to be testing TTS streaming audio. Is there anything that I can...
Huh. I don't know if that has something to do with my print function here. Maybe. Or my print call. Hey, maybe print is a function too, so. But if you look at the first, where is it? First inference. Oh, weird.
Today we are going to be testing TTS streaming up to audio. Is there anything that I can do to help you out? Or maybe you just like a quick snack? If not?
Huh. So, yeah, I'm not sure exactly why why we're getting issues. I kind of have an idea on why we're getting issues there. Alright, let's try that one more time. This is with the queue needing 2 samples first before it starts to speak out audio.
Today we are going to be testing TTS streaming audio. Is there anything that I can do to help you out? Or maybe you just like a quick snack? If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Oh, I know why. Because I am putting in the first I'm slapping in the audio cue, that first little fragment each time. So what I should do instead is just do that, and we should be fine. Alrighty, let's slap these in here. I'll copy these actually and comment this out. Let's go tab it. Alright. Okay. Alrighty. That's what was happening. Alright, but this is going to be the last inference, and that's going to be pretty much it for this offline live stream that I've been doing, and hopefully you guys found some things insightful in this and interesting. So let's start enter.
Today we are going to be testing TTS streaming audio. Is there anything that I can do to help you out? Or maybe you just like a quick snack? If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Ah, okay, wait, hold on. I need to put this fragment, audio queue.put fragment. I need to put that in right here. Because yeah, I didn't hear that first sample. And now this has to be changed to here. I will put another one here. Right, let me okay, now this should genuinely be time to first fragment, correctly done and timed.
Today we are going to be testing TTS streaming audio. Is there anything that I can do to help you out? Or maybe you just like a quick snack? If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Alright, now let's do it on the second one. This is the true test of the speed.
Today we are going to be testing
0.79.
TTS streaming audio. Is there anything that I can do to help you out? Or maybe you just like a quick snack. If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Okay, wait, hold on. I think I've been doing my timing incorrectly.
Today we are
Okay, 0.8. Oh, man. Forget the past 30 or so minutes. I've been timing this incorrectly the whole time. I need to have my start time here rather than here. Okay. So let me just retime this real quick. Let's try. Forget everything you saw for the past 30 minutes in regards to timing. Because I had the start time in the wrong section.
Today we are going to be testing TTS streaming audio.
7 seconds. Wow.
Is there anything that I can do to help you out? Or maybe you just like a quick snack. If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Okay, so time to first fragment after the first generation. Let's see.
Today we are going to
1.5
be testing
seconds.
TTS streaming audio.
That's still okay.
Is there anything that I can do to help you out?
Not as egregious as I
Or
thought.
maybe you just like a quick snack. If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Alright, 1.4.
Today we are going
1.3. Okay. That sounds about right. Yeah. 1.3 for this solution here. And then now if we try this without the dynamic accumulation, let's go false. Say this to 30. Alrighty. This is with the static accumulation.
Today, we are going to be testing TTS streaming audio. Is there anything that I can do to help you out? Or maybe you just like a quick snack. If not, that's okay too. I'm just here to chat and maybe become friends, as I don't meet many people in this world.
Alright.
Today, we are
1.7. Alright, cool. So 1.7 versus 1.5. So overall, doing this dynamic accumulation is faster. Which is good. Good to know. And yeah, there are probably some additional optimizations that I can do. But yeah, I've got to end it here, unfortunately, and upload this to YouTube. But hopefully you guys found this interesting. You know, if there's anything that you learned from this, let me know. I learned some things from here. So yeah, I'll probably be making maybe like another video on this, because, you know, I'm not done with this yet. And like this style of recording, to me, it's a little bit easier for me to get out content this way. So I can just get all these things out there, and then when I want to make a curated video, of course I can make a curated video. But curated videos take like 5 to 10 times longer than this. But yeah, that'll be it, and see you guys later. Thank you.